Hi class, Mr. Hajduk here. Obviously I'm not in class today. However, I'd like to go ahead and start our second unit with our lab that is going to help us learn about some cool graphing techniques and some cool data analysis techniques. Let's take a look at what we're talking about. So first things first, let's go ahead and define the thing that we're going to be working with in your classes. We're going to be working with what's called a pendulum. Now, a pendulum is made of three parts. The first part is that there is a connection point up here at the top, and attached to that connection point is a length of string, and attached to that string is a mass. And the idea here is that when you displace the mass a certain angle here, like we see it's 15 or 16 degrees, and I release it, the mass is going to oscillate back and forth. So the question that I'd like to ask you, and I'd like for you to take a moment and talk with your group about, is I'd like for you to come up with some items that we can measure about this system. Now recall here that when we talk about measuring, we're not talking about calculating. So it needs to be something that I can actively measure with a tool. So go ahead and pause the video and talk to your group about what items you can measure from this system. All right, so hopefully you had a good opportunity to talk with your table partners about what you're going to need to do, or rather what you can measure from the pendulum system. So first let's go ahead and draw our pendulum in here, so that way we can kind of like see what we're trying to talk about. And so again, I've got my connection point, we'll call label P. We've got our string length, I'll call label L for length. And we've got our mass here, I'll call label M. So M for mass, length for L, and P for connection point, or point of contact. Basically, it's just the knot that's at the top of your apparatus. Alrighty, now as we saw in the video, and this is the first thing that we can measure here, we saw that when we displaced this pendulum an angle from the vertical and release the mass, that the mass would oscillate, meaning it would go back and forth. Okay, so some items that we can measure. I think the first thing that we can measure, like we just talked about here, is the angle. Now the angle that we're going to measure here, we're going to use a protractor. And you're going to measure it from the vertical. So I'm going to say measured from the vertical. Awesome. The next thing that we can measure is we can measure the length. So if we wanted to measure the length, I think the best use of a measuring tool would be some sort of meter stick, or specifically a 2-meter stick. And the reason why is because obviously if you take a look around the room right now, the string lengths that you guys can use are very large, and I don't think a 1-meter stick is going to be big enough to use it. I think the third thing that you can measure is you can measure the mass. So the mass here, I think we're going to use washers. So we're going to say, using a scale, place washers one at a time on the scale, and then you can incrementally increase your mass. Now the last thing that we are going to measure is we are going to measure the amount of time it takes for this object to oscillate. Now that time has a very special name, and that's called the period. So the period is the variable for time that we are going to measure for this motion. And it's the total time it takes for the pendulum to swing once forward and back, otherwise known as one oscillation. So an oscillation means that we are going to go forward, and then we're going to go back, and we're going to time that time, and that's going to be the period. Now the period is going to be difficult to time, so I want to make sure that we understand that we're going to use a stopwatch, obviously, to measure this. But I think the best thing for us to do is to take 10 full swings and time those. We'll call that the total time. And then we're going to divide that by 10, and that should get us the period. So we're going to take 10 full swings. That is once, and then twice, and then as you can see as I'm continuing to draw here, but you're going to take 10 total swings. That's forward and back. Take that value of total time, divide it by 10. That's going to give you a better average for our period. So those are the big four that we are going to tackle. So we're going to tackle the angle, the string length, the mass of the washers, and the total period of our pendulum. So that brings us to kind of a big important feature here, and that is our purpose. Our purpose for this lab is going to be to graphically and mathematically model the relationship between our four variables here. So we're going to develop three unique experiments with these values. The first one is going to be theta versus the period. Next is going to be string length versus the period. And then the third one is going to be the mass versus the period. So that means that our independent variables are going to be the following. They're going to be the angle theta, the length L, and the mass M, because all three of those are easy for us to change. You change the angle by increasing the angle here to something larger, say out here. So you're going from one angle to the next angle, right? Length, it's simple. You just change the length of the string from the shorter spot to the longer spot. Mass, you're going to change the number of washers. So if I have one washer, well, I might add another washer and another one, et cetera, et cetera. So those are all pretty easy to change. And then we're going to test how changing those variables affects the value of our period. So now this brings us up to the data table and lab setup. Kind of already talked about the lab setup here on the right, but the data table, what we're going to do is you're going to select a number of different angles, and we are going to keep all the angles less than 20 degrees. So pick 8 angles less than 20 degrees. And what I'd like for you to do is I'd like for you to let the rope swing back and forth 10 full swings, then divide that by 10, and that's going to give us the total period that we are going to put for each of those data points. So it's going to be a lot of swinging, but that's okay. Then what I'd like for your group to do is I'd like for you to repeat that cycle, but this time instead of your 8 different angles, I would like for you to pick 8 different lengths. Once again, you're going to then compare that with the period, which you're going to find by taking 10 full swings, dividing it by 10, and getting your period that way. So you'll have 8 total periods that correspond with your 8 total lengths. Finally, you're going to do the third experiment, which is to pick 8 values of masses, which is to say you're going to have 8 washers, or you can go up by a different number of washers. That's totally fine. Starting with obviously 1 washer and the mass of it. And the scales, by the way, are at your desk. And you're going to measure, again, how those masses affect your period by taking 10 full swings, dividing it by 10, and then you can get your 8 period values. Once you've completed 2 of those experiments, then you're finished for today. I want you to graph 2 of those experiments. So everyone is going to pick length for reasons that I know and that you'll know later. And then you can pick either your angle experiment or you can pick a mass experiment. But what I'd like for you to do is I'd like for you to talk to your neighbors and choose a lab that's different than theirs. But everyone's going to do this. Everyone's going to do the length. And then you're going to choose either this one or this one. Okay? Alrighty. Take the data, get it all finished, throw it into Logger Pro, and then jot those graphs on the next page in your lab. All right, I'll be back on Monday. We'll reconvene then. Best of luck today, and I will see you on Monday. All right, bye-bye.